Hey y'all, in today's video, we're going to take a look at the evolution of the atomic model over time. We're going to start at kind of the origins and finish where we know today to be when it comes to what the atom looks like, how it's made, and how each of the different components of it behave. So let's go ahead and get started. The concept of the atom is thought to originate with the Greeks several thousand years ago, where they had this concept that you could continue to divide and divide and divide and divide matter until you get to something that is indivisible. They called this the atom, which literally meant in Greek, indivisible. And so an atom at the time was thought to be a small sphere, a solid ball of stuff, of matter. And this matter was the origin of what we now know as an atom. And this atom that we now know has evolved over time. After the Greeks, the next big step in the atomic model was in Dalton's era, and Dalton postulated the law of constant composition, which is considering that every compound must be made of the same types of elements. So all water molecules, for instance, must be made of 2 hydrogen atoms and 1 oxygen atom. All carbon dioxide molecules must be made of 1 carbon and 2 oxygens. This is the law of constant composition. Also, he had the idea of the law of conservation of matter, which is the idea that we have no way of destroying or creating matter that exists. You can change it chemically and physically, but you can't create nor can you destroy matter. Dalton theorized that everything was made of atoms. He theorized that all things that were made of atoms, those atoms could be rearranged into different components and different groups. So we have the law of constant composition, but then we also have the law of multiple proportions, which is that you can have the same 2 elements comprised only in a compound, and all of that will change. So the idea of butane, which is a different number of carbons and hydrogens than methane, which is a different number of carbons and hydrogens than propane. All 3 of these compounds have only carbon and hydrogen, but they're all 3 very different compounds because they come in different numbers. They're in different ratios. The next person who really played a huge role in the development of our atomic model was J.J. Thompson, who did something called the cathode ray experiment. Basically, what he did was he shot electrons off of atoms, but he didn't know at the time that atoms had electrons. So he shot these electrons off of atoms and realized, because he passed them through a field, that they were negatively charged. So now with the J.J. Thompson model, the idea was that we have this sphere of a little bit of positivity in an atom, but studded throughout it were negatively charged electrons, these tiny little particles. Now, here's the thing. We call this the plum pudding model, all right, which is very British. All right. You could also call it the chocolate chip cookie model, because you can think of the atom looking a little bit like a chocolate chip cookie with all those chocolate chips kind of studded throughout. All right. If the whole cookie is a little bit positively charged, each of those electrons is negatively charged, the whole atom stays neutral the way they knew it was. So that was the Thompson edition. After Thompson came a guy named Ernst Rutherford, who shot beams of particles at gold foil. And in theory, if this was a solid wall of positivity, all right, that Thompson had kind of theorized, all those would have bounced right back. It's like shooting something up against the wall. You shoot a tennis ball against the wall, it's going to bounce back. However, what he realized was most of the particles went straight through. That means the atom must have been mostly made of empty stuff. Some of it, though, bounced straight back, which meant there must have been a positive something in there. He called this the nucleus, a small, very dense, very heavy, relatively speaking, area right in the middle of the atom that takes up a very small amount of space, but packs a punch. It's a very positively charged thing. This led to the understanding of protons, the positively charged nucleus, surrounded by electrons. Niels Bohr then came along and said, well, each of these electrons seemingly has different energies. This created the Bohr model. The Bohr model is what you're going to normally see when you're drawing atoms, where it's going to be a little nucleus in the middle, followed by rings, concentric rings, like planets around the sun, of electrons surrounding the nucleus. And here's the thing. That's not necessarily right either. All right, because we have now evolved into our current model of the atom, the quantum model of the atom. That's where we're at now. So let me briefly describe the quantum of the atom. And I need you to understand the quantum model of the atom is where we're at now, but we're still evolving, and it goes a little bit deeper than what I'm going to go with you. Okay, I'm going to keep it shallow and keep it simple for you right now. So here's where we're at right now. The atom has a nucleus in the middle that is made of protons and neutrons. Protons are positively charged. Neutrons are neutral. They each weigh 1-ish atomic mass unit. That is surrounded by clouds of electrons. These clouds of electrons are electrons that exist around the nucleus, but they are never still. They never stop moving. They're always going to be flying around the nucleus at crazy speeds and with different amounts of energy. Some electrons have more energy, some electrons have less energy. The amount of energy they have is based on how close to the nucleus they are. Those that are closer to the nucleus versus those that are further from the nucleus have different amounts of energy. Electrons can jump in energy. They can go up in energy. It takes energy to do it. But then they can fall back down. And when they fall back down, they release energy. Okay? Then, beyond that, they exist in these things called orbitals. Orbitals hold 2 electrons each. 2 electrons each per orbital. And these orbitals predict, based on shape, where electrons are going to be. You don't need to know the shape of each of the orbitals. However, in future chemistry classes, you might. You might need to know that the s orbital is shaped like a sphere and the p orbital is shaped like a dumbbell. But you don't need to know that here. We're going to learn about electrons and electron configurations and where they exist in these orbitals in a later video. Right now, I want you to know the term, orbitals. These orbitals exist in subshells or sublevels. And depending on which sublevel or subshell they're in, there's a different number. Then these subshells or sublevels exist in energy levels, which kind of goes back to the idea of the Bohr model, where these energies had different rings, right? Different shells at different distances from the nucleus. That's kind of right, but it's not completely right. Because here's the thing, an electron that exists on this outer shell, yeah, sometimes it dives in really close to the nucleus and sometimes it falls back away. It depends. So we can think of energy levels as how far on average an electron is from the nucleus. We can think of a subshell or a sublevel as the general shape in which that electron exists within that. The orbital we can think of as the specific place that a pair of electrons tends to hang out. And then we've got the nucleus that is covered with neutrons and protons existing together. Okay, so this video was packed with thousands of years of history of the atom. So what do you need to know? First of all, you need to know our current model of the atom, the quantum model. And you need to be able to use the terms appropriately. When I say orbital, subshell or sublevel, energy level or shell, you need to know what I'm talking about. You need to know the components of the nucleus, protons and neutrons. You need to know, generally speaking, how each of the particles in the atom exist. Protons being positive, neutrons being neutral, electrons being negative. You need to understand that electrons have different amounts of energy based on how far on average they are from the nucleus. Finally, what do you not need to know? I don't need you to try to memorize all the names of the different scientists. I don't need you to know any of the dates or the years or anything like that. That's wonderful if you know it, but it's superfluous to our needs right now in this course. In general, understand how the atom got to where it is now in terms of what we understand about it. It's great if you know the experiments that led to that, because those experiments are going to help you consolidate and truly understand the information a little bit better. But in the end, if you walk away from this video knowing more about the atomic model as it currently exists, you're in great shape. Today's video was written, directed, produced, and edited by Megan Greeley. I'd like to thank you all for watching it. I hope you enjoyed it, and I'll see you in the next one.